Hurricanes and tornadoes are two of the most powerful and destructive forces in nature. Both storms unleash extreme winds, torrential rain, and devastating destruction, but they form in very different ways. A hurricane is a massive storm system that develops over warm ocean waters and can span hundreds of miles. A tornado is a much smaller but more intense storm that forms over land, often from severe thunderstorms. Hurricanes can last for days or even weeks, while tornadoes typically last for minutes to an hour at most. Scientists have long wondered whether a hurricane and a tornado could ever merge into a single superstorm. On the surface, it seems possible since both involve rotating winds and violent weather conditions. However, their differences in formation, structure, and scale make a true merger highly unlikely. Hurricanes form over warm ocean water, gaining strength from the heat and moisture in the atmosphere. Tornadoes, on the other hand, require strong wind shear, instability, and rapidly rising air in thunderstorms. While hurricanes generate multiple small tornadoes, these are very different from a true tornado-hurricane fusion. Hurricanes produce large, stable rotations, while tornadoes rely on chaotic, fast-moving wind patterns. If a tornado were to form within a hurricane, the two systems would not merge, but rather exist simultaneously. Hurricanes create ideal conditions for tornado formation due to their intense wind shear and thunderstorms. Most hurricane-spawned tornadoes occur in the outer bands, where powerful thunderstorms rotate independently. Unlike tornadoes from regular storms, hurricane-spawned tornadoes tend to be weaker and shorter-lived. The strongest tornadoes form in supercell thunderstorms, which rarely occur inside a hurricane's structure. Because hurricanes have widespread rotating winds, they prevent the kind of instability needed for strong tornado formation. If a tornado were to form inside a hurricane's eye, it would likely be short-lived due to the lack of wind shear. Scientists believe that even if a strong tornado formed inside a hurricane, it would not sustain itself for long. The immense size and slower rotation of a hurricane would disrupt the faster, tighter spin of a tornado. Tornadoes rely on focused, high-speed rotation, whereas hurricanes generate massive, slower-moving circulation. In a direct collision, the tornado would likely be absorbed or disrupted by the hurricane's larger wind field. This means that rather than merging, the tornado would simply disappear or weaken inside the hurricane. However, hurricanes can produce dozens of tornadoes, leading to widespread destruction beyond the storm surge and winds. The most tornadoes ever recorded from a single hurricane occurred during Hurricane Ivan in 2004. Ivan produced a staggering 120 tornadoes across the southeastern United States after making landfall. These tornadoes formed in the hurricane's outer bands, where the wind patterns were most favorable. Another devastating example was Hurricane Katrina in 2005, which spawned more than 50 tornadoes. Hurricane-spawned tornadoes are often weaker than supercell tornadoes, but they can still cause significant damage. If a tornado and a hurricane were to meet directly, the tornado would likely be overwhelmed by the hurricane's force. A hurricane's massive low-pressure system dominates its surroundings, while tornadoes form in smaller, localized areas of low pressure. Since hurricanes operate on a much larger scale, they do not have the conditions necessary to sustain a tornado for long. Even if a tornado survived inside a hurricane, it would not grow stronger by feeding off the hurricane's energy. Instead, the hurricane's turbulent winds would disrupt the tornado's structure and cause it to dissipate. Despite the differences, hurricanes and tornadoes do share some surprising similarities. Both storms are driven by rotating air currents and rapid changes in pressure and temperature. Both can produce winds exceeding 150 miles per hour, though tornadoes can reach much higher speeds. Some of the strongest tornadoes have been recorded with wind speeds over 300 miles per hour. The strongest hurricanes, like Category 5 storms, can have sustained winds over 180 miles per hour. The damage from a tornado is usually confined to a narrow path, while hurricanes affect entire regions. A tornado's destruction comes from extreme wind speeds, while hurricanes cause flooding, storm surge, and long-term damage. Scientists have explored whether climate change could create conditions that make tornado-hurricane interactions more common. As ocean temperatures rise, hurricanes are becoming more intense, producing stronger storms and more tornadoes. Warming temperatures may increase the number of hurricane-spawned tornadoes in the future. However, a full-scale merger between a hurricane and a tornado remains scientifically improbable. The conditions needed for each storm to thrive are simply too different to allow a true fusion. Even in extreme cases, a tornado would likely be short-lived within a hurricane's environment. Hurricanes create pressure fields that stretch for hundreds of miles, limiting the formation of small, tight rotations like tornadoes. Because of this, the idea of a superstorm combining both forces remains more fiction than reality. However, hurricanes can lead to tornado outbreaks even after they weaken over land. As a hurricane moves inland, it loses its connection to warm ocean waters and starts to break apart. This weakening process can create severe thunderstorms, which may spawn tornadoes in the storm's remnants. Some of the deadliest tornado outbreaks in U.S. history have been linked to former hurricanes. Hurricane Harvey in 2017 caused dozens of tornadoes as it stalled over Texas, creating massive damage. Hurricane Andrew in 1992 produced multiple tornadoes even after its winds weakened. The combination of hurricanes, tornadoes, and flooding makes these storms some of the most destructive on Earth. While a true hurricane-tornado hybrid is unlikely, the effects of both storms can overlap in devastating ways. In the rarest of circumstances, an extremely powerful tornado could survive near the edge of a hurricane. However, this would still not lead to a combined storm, as the two systems function on entirely different scales. Tornadoes feed off rapidly changing wind patterns, while hurricanes rely on stable heat energy from the ocean. Even if a tornado formed inside a hurricane's eye wall, the hurricane's chaotic winds would eventually tear it apart. Scientists continue to study how extreme weather systems interact, but so far, no evidence suggests that a true fusion is possible. The more likely scenario is that hurricanes will continue spawning tornadoes, especially as climate conditions change. Advances in storm prediction and monitoring technology help scientists track both hurricanes and tornadoes more accurately. Doppler radar, satellite imaging, and AI modeling are improving our ability to predict tornado formation inside hurricanes. While nature can create incredibly powerful storms, the physics behind hurricanes and tornadoes prevent them from merging. However, the destruction caused by both systems remains a serious threat to millions of people every year. Understanding how hurricanes and tornadoes form is crucial for improving warning systems and disaster preparedness. Emergency response teams rely on meteorologists to predict when and where these storms will strike. As our understanding of extreme weather grows, so does our ability to minimize damage and save lives. Despite the differences between hurricanes and tornadoes, both are reminders of nature's raw power. Each storm type presents unique dangers, and together they shape the landscapes and climates of the world. While Hollywood might imagine a scenario where a hurricane and tornado merge into one superstorm, science tells a different story. Nature's forces are already powerful enough on their own, and the impact of each storm is devastating in its own right. For now, tornadoes and hurricanes remain separate forces of destruction, each leaving its own mark on history.